This report is a bivariate and pattern analysis looking at how ground surface reflectivity affects the relationship between solar exposure and temperature in Australia. Ground surface reflectivity is when solar exposure from the sun is reflected by the Earth's surface rather than being absorbed. This process may be referred to as albedo, one of the major properties that controls how much energy is absorbed by the surface of the Earth. Solar exposure warms both land and water surfaces. However, water has a higher albedo and is more reflective due to its conductivity and ability to distribute the heat to larger depths. Land surfaces, by comparison, are poorer heat conductors as they have less capacity for evaporation and heat distribution, instead absorbing heat from solar radiation. From this, one may infer that land surfaces reach higher temperatures faster and for longer when comparing to temperatures in regions surrounded by water. The following statistical analysis poses the question, how does ground surface reflectivity affect the relationship between solar exposure and temperatures in Australia? The data was recorded from both coastal and inland locations of similar longitude and latitude coordinates for the states South Australia, Western Australia, and the Northern Territory. The stations were strategically chosen in order to provide a fair sample dataset for the period 2016 to 2020. The bivariate and univariate statistics were performed and calculated using Excel. It should be noted the boxplot graphs for all weather stations have been excluded from this presentation due to technical difficulties. They are available to be viewed in the statistical analysis spreadsheet. Here we have both the bivariate and univariate statistics for Hawker Weather Station located inland in South Australia. From the data shown in Figure 1 and Table 1, we can see a strong positive linear association between solar exposure and temperature. From the univariate statistics in Tables 2 and 3, we can see the mean minimum temperature recorded is 16.22 degrees, with the maximum averaging at 35.62 degrees. Our second South Australia weather station is Elliston Station, located coastally. From the data shown in Figure 4 and Table 4, we can see a moderate positive linear association between solar exposure and temperature, indicating a weaker relationship between the two. The univariate statistics show the minimum temperatures recorded average to be 17.20 degrees, with the maximum averaging 27.84 degrees. Here we have both the bivariate and univariate statistics for the Bencubben weather station located inland in Western Australia. From the data shown in Figure 7 and Table 7, we see another moderate positive linear association between solar exposure and temperature. From the univariate statistics in tables 8 and 9, we can see the minimum temperatures recorded average to be 16.58 degrees, with the maximum averaging 34.78 degrees. Our second weather station in Western Australia is Kalbarri, located coastally. From the data shown in Figure 10 and Table 10, we can see a weak to moderate positive linear association between solar exposure and temperature, indicating even less of a relationship compared to the previous weather stations. The univariate statistics show the minimum temperature recorded averages to be 22.16 degrees, with the maximum averaging 33.68 degrees. From the Camberwell Township weather station, located inland in the Northern Territory, the data shown in Figure 13 and Table 13, we can see a strong positive linear association between solar exposure and temperature in this area. The univariate statistics show the minimum temperatures recorded average to be 26.76 degrees, with the maximum averaging 40.68 degrees. Our second Northern Territory weather station is Swears Island Station, located coastally. The data in Figure 16 and Table 16 shows a weak positive linear association between solar exposure and temperature, indicating a poor relationship. The minimum temperatures recorded average to be 22.16 degrees, with the maximum average reaching 33.68 degrees. We see from the statistical analysis findings, the weather stations in Elliston, Kalbarri, and Swears Island recorded weak positive linear relationships between solar exposure and temperature. In comparison, the weather stations in Hawker, Bencubben, and Camberwell Township all recorded moderate to strong positive linear association. It may be concluded that this is the result of ground surface reflectivity, as land surfaces absorb more solar radiation and therefore warm quickly for longer, whereas the areas surrounded by water have a higher albedo, with greater surface reflectivity. The solar radiation is reflected back into the atmosphere, meaning the temperatures are changing at a slower rate. We see this reflected in the data for the coastal weather stations. Minimum temperatures were recorded higher than those from the inland weather stations, with the maximum temperatures recorded lower at the coastal weather stations than at the inland. Therefore, we can say ground surface reflectivity affects the correlation between solar exposure and temperature in Australia. Thank you.